Okay, well, all right. Before I actually put the new problem up, I will show you what I'm attempting to do. All right, here we have just a general representation of what the graph of cotangent looks like. We see that it's a decreasing function, and normally, if it's untransformed, it has a period of pi, and the asymptotes are at y equals 0 and y at, I'm sorry, x equals 0 and x equals pi, and the period is pi. Okay, now we're going to attempt to see the effects of the coefficients a, b, and c from the general form of the cotangent function. Now we're going to ignore d for the purposes of this demonstration, because all d does is shifts the whole graph once it's drawn up or down depending on what the value of d is. All right, we'll start with a pre-made example of y equals 1/2 cotangent of 2x plus pi. Now I already labeled what my coefficients are. A is 1/2, b is 2, c is negative pi. Notice that this has a plus in here, and we assume by our definitions that that should be a minus. D is 0, like I said before. Alright, so what does b affect? B affects the period, which is defined to be pi over b value. So in this particular case, our period will be pi over 2. Now the phase shift is defined to be as c over b. In our case, the c is negative pi, therefore the phase shift is negative pi over 2. So let's actually put this on paper. Let's start graphing it. Now we know that the phase shift in cotangent function, the very first thing it affects is the left asymptote, and that's what we want to place. We want to phase shift negative pi over 2 and place our asymptote, our left one. Alright, so if this is pre-labeled as negative pi, my midpoint would be somewhere here, and that would be negative pi over 2, and I would simply put an asymptote here. Now, since my period goes pi over 2 in the positive direction, well, actually goes in both directions, but the one we're concerned with is in the positive direction, pi over 2 from negative pi over 2 will land us on the y-axis. Now, I don't know if you could, I hope you could see that. Yeah, you could see that. This is my asymptote. Okay. Now we're trying to place this point, this 0. Now, in a untransformed case, the 0 lied at pi over 2, but in this case, it lies in the midpoint of this period, of this interval. And since this is negative pi over 2, this would be pi over 4 negative. Okay, we know that the function will go through this point, and generally it's going to look like this. Now the only question remains is what happens at these at quarter interval points, and what are they? Okay, if this is my quarter, pi over 4, and that's half my period, what is a quarter step? The quarter step would be negative pi over 8. That's my x value. And in this one, of course, will be 3/8, right? 1/8, 2/8, 3/8. Yes, yes, my math is correct. Okay, so this point will be negative 3/8 pi. Now it's getting a little difficult to see, but I think we're okay. So what happens at these points? In an untransformed case, going back to this point would correspond to value 1. Think of a 45-degree angle, which is 1/4 of the period. At 45, which is pi over 4, our y value is 1. But in this case, our y will be affected by the vertical stretch of 1/2. A is 1/2, therefore, in this case, it's not at 1, but it actually is at 1/2. So we'll place that dot. You know what? Maybe actually I will see if this is better. All right, it's the red dot. I can't quite tell. Red dot. So we know it's going to go through here. It's going to go through this point. Now what happens on at this point? Well, again, instead of being at -1, it's actually at -1/2. And that's at 1/2. So let's put that dot down. Okay. You can't quite tell the color for some reason. Now, we know at this point it's going to hit the asymptote in the positive infinity side, and this is going to be negative infinity. So it's just a matter of connecting these points in a nice fluid graph. Okay, and there's generally, that's a pretty nice representation of what I'm actually trying to draw. And as you can tell, it's beginning to come very close to the x-axis because my a value is a fraction. The smaller the value, in other words, the bigger the denominator here is, the closer it'll hug my x-axis. And of course, we'll see in the next example just the opposite effect. But there it is. That's a transformation of this function, and here is its graph. Oh, of course, one thing I should mention, of course, we are showing only one period of the whole graph. It does repeat itself, so if we wanted to see what happens in more than one period, we would label it appropriately and generally connect the dots, something like this. But since for our purposes we really want to see what happens in one period, plus on the test that would only require one period representation. Okay, have fun.